Are you relation? Do you remember that the last like day of grade 11, we just weren't like always looking graphs?
Oh yeah, like the volcano. The
Yeah, are you gonna do that to us again?
The pothole.
We'll relearn those.
You're just gonna like last day. You're gonna give us all this stuff we have to know.
Oh, for sure.
You have to know this.
Yeah. In fact, I'm just kidding. You said there's 2 units left. We have 15 units left. I just hid 13 from you. The additional 13
How many
units.
we done?
I'm kidding.
6?
I'm kidding.
We got 6.
We've done. This is unit 6. So we factor first.
I thought there like wasn't enough time to finish the class in the class period of time.
We're finishing. We're going.
Like he kept saying like, oh, like you have to rush and you finish with like a day left in the semester. But we've wasted a few classes.
Thanks. Thanks a lot.
It's true.
You're already doing great, no cry.
Yeah.
All right. X can't equal -2 and x can't equal 2.
They should. He's gonna cry now.
Those
That's it.
poles or vertical asymptotes?
Vertical
asymptotes. They don't cancel out. So I'll have 1 at -2 and 1 at +2. Which group is this? Group 3, bigger on the bottom. Group 3 is the easiest one, I think. Horizontal asymptote at y = 0. Okay. So we start drawing. Once you've figured out all of your asymptotes, and start drawing, take out your red pen, put that asymptote in.
Is this your JRS?
This one has separated the graph into 3 sections, just like I mentioned that if we did 2b, it would have separated it into 3 sections. Y-intercept is the easiest to find. Plug in 0 for x. I like to go back to the original equation. You see that you have -4 over -4? 0, 1. Label the point. Next, x-intercepts. Go to your factored version, just look at your numerator. The bottom would cancel out. 4, 0. Uh-oh, this is gonna bother you. 2, 3. It's right on your asymptote. That's weird. So, when we go to graph, do we need more nice points? Yes. Do we have anything in section 1? We have nothing in section 1. So what I would do is I would plug in -3 into my equation. Either my original equation or my factored one, doesn't matter. If you plug in -3, do you see the top will be -7?
Yeah.
And the bottom will be 5. -7 over 5. Label that point. That'll be like right there. -3, -7 over 5. That's enough to draw that section towards the asymptotes. Do we have a point in the section 2? We do. Do we have enough to graph it? We do. We know that it has to go up towards the asymptotes on both sides. It can't go down because then you would have another x-intercept, and we found all the x-intercepts, and the only x-intercept is at 4. So we can't go down because that would make new x-intercepts. Therefore, that section is done. Section 3. Normally a point in a section is enough, but unfortunately this point is on the asymptote. I don't know if it goes up or if it goes down. So, what do I have to do? I have to have another nice point. I probably will choose 3. What happens when you plug in 3? You see that the top would be -1 and the bottom would be 5. So -1 over 5. Okay, that tells me I at least know this has to happen. What could happen here after 4 is the graph could go up and come back towards the asymptote, or it could bounce off and then go back towards the asymptote. I'm going to find out what it does. I'm going to plug in 5. I'm going to get another nice point. If I plug in 5, the top will be 1, the bottom is 21. So I know that it'll go up, hit this point, and eventually come back down towards that asymptote. Because that asymptote just says what's happening at infinity. Yes.
What if it kept going up?
It could go up higher. I don't need to know how, I just needed to know it went straight through and then came back down. A couple of things that we can use from other units. The x-intercept of 4 had a multiplicity of 1. So we would know the graph has to go through it, not bounce off of it. We'll see that come up in these units as well.
Wait, why is it called an asymptote if it doesn't behave the same way as the vertical? Like, why isn't there
An asymptote is drawn to tell you information about how the graph behaves. They both do that. The horizontal one, though, just tells you information of how the graph behaves at infinity. The vertical one is always a non-permissible value, and therefore it can't go through it. But it still shows you that the graph, in both situations, the graph eventually approaches it and gets closer to it. But in one situation, it never can go through. In the horizontal, sometimes it goes through. So this was a weird situation. This is probably the weirdest graph. I've never seen this weird one show up on the exam, but it's possible. Okay? We're getting interrupted right now, so I'm going to leave you 3B. If you want to see it, I have it posted online. And 4 is graphing technology. You can use Desmos or a graphing calculator. Type this into Y1, this into Y2, and see where they intersect. That's all we would do for 4.
Are you doing this?